EIGRP security. Many moons ago, I used to teach 100% in a classroom environment, and I still remember teaching a CCNA class probably 10 years ago or so. It's weird to say that, but I'm doing a demonstration on EIGRP, doing the basic network commands, and I come back out and do a show IP route, and I'm like, whoa, look at all these routes. I have no idea where these are from, and we're all staring at this overhead projector of these routes. Probably 2 seconds after I say that, somebody comes crashing in the door of my classroom saying, oh, the network's down, internet connection's down, we're on the phone with the ISP now, and I'm scratching my head trying to put the puzzle pieces together. And it didn't take me long to realize, I'm like, oh my goodness, we just formed a neighbor relationship with the backbone of this training center, and I'm injecting default routes and all this crazy stuff that hosts up their network. So I just unplugged my little lab pod from the wall, and of course, miraculously, everything came back up, and I totally did not admit a thing. When they came back in, it's, I don't know what happened. So anyway, EIGRP, very friendly protocol, right? Just says hello to anybody else that's out there that wants to form a neighbor relationship. And on a good day, you could probably form a bad neighbor relationship that you didn't expect with a non-malicious device. On a bad day, you can actually get malicious people that are out there to sabotage your routing table. So really, EIGRP security boils down to two methods. Number one, passive interface. Number two, authentication. The passive interface command is so awesome because it's simple. It simply turns off EIGRP hello messages. See, here's the deal. We go into EIGRP and make it the friendliest protocol in the world because we type in these network commands. Network 10.0.0.0, right? Network 172.30.0.0. And when you do that, that does two things. One, it says advertise all these networks because they all start with 172.30 to all the neighbors, right? To all the neighbors that it would form. The second thing it does is say send hello messages out. That's number two. Send hello messages out on any network that begins with 10. So form neighbors here, and send hello messages out on any network starting with 172.30. That's over here. All the passive interface command does is turn off number two. Meaning it says still advertise those networks to the rest of the world, but don't send hello messages. Think of that, how awesome that is, because it's so simple. We're no longer going to form neighbor relationships on whatever networks we include with the passive interface command. So check this out. I just really lazy went in there on all these routers and enabled EIGRP, no auto, and then typed in the couple network commands. I can actually go in here and type in, let's go router EIGRP 10 and do passive interface. And then what interface do I want to do it on? Let's just do 00/0 just to demonstrate that immediately the neighbor will go down on that interface because it says, hey, I'm done sending hello messages to you. So we're not, I'll still advertise whatever network was on 00/0, but I'm not going to form a neighbor relationship. So check out Cisco's best practice, right? Passive interface default. It's all alphabetical except that one, right? Why did they do that? I don't know. So passive interface default says turn off EIGRP hello messages everywhere except where I go in and type in no passive interface and then the interfaces that I want to run it on. Pretty slick, huh? That makes sure that when I add interfaces to EIGRP, it doesn't automatically form neighbor relationships until I go in and essentially say, for this interface, run EIGRP. With that in mind, you can add that passive interface default command to your list of commands that you should type when you're first starting every EIGRP process. You type in no auto summary, passive interface default, then your network commands to make sure that you know exactly when and where EIGRP is going to establish neighbor relationships. Cool. All right, second method that we can use to enable EIGRP security is authentication. So here's the deal. Every single packet, when we turn on authentication, will be hashed. Meaning, we go in and define a little pre-shared key. Let's just say the key is secret ninja, S-ninja, right? So I type that in as the pre-shared key. EIGRP, every single time it sends a message, so let's just say a hello message or a update message or anything, it's going to take that pre-shared key, hash it together with all the contents of that message. So let's just say that update message said, hey, the 10 network is down, or something is in there. You got some header stuff and all that kind of stuff in there. It takes that packet along with this secret ninja, puts it into this hashing blender. It's actually MD5 hashing if you want to know the specifics of it. We kick it on and it spits out this big long hash that it sticks at the end of this packet. So keep in mind, this is not encryption. This is not like if I have a wire sniffer, I'm still going to see everything in plain clear text, even the hash. I'll see this gobbledygook at the end of the packet saying, hey, here's a hash. But the key is when it gets, get it? Key? Pretty sure. The key is when it gets over to the other side. The other side takes all that content, takes the pre-shared key typed into that router, puts it into that same blender, and it says, okay, do I get the same answer that's in the end of that packet? That's what hashing is all about. That's why they call it authentication, not encryption. If it spits out the same answer, it's like, okay, sweet, we've got the same pre-shared key then. We're good to form neighbor relationships. If it doesn't spit out the answer, then it's going to say, hey, you're a rogue ninja router. You're sending stuff to me that I don't want to accept it because you must not have that same pre-shared key. It's so powerful because I don't know. I get excited when I see these kind of things. I get excited about everything, but I get really excited when I see this because I'm like, that's so cool. That somebody in the middle, let's say evil person X sitting here in the middle, eyeless man, grabs some packets right here. He gets this hash. He gets all the content of that, and he still can't figure out how to generate that formula, or can't, like I always, my simple math brain, I'm like, okay, X plus let's just do, because I wrote it wrong, 5 plus X equals 10. I'm like, okay, so X is going to be 5, right? Same thing here. He's like, I've got the hash, I've got the content that generated the hash, I'm just missing this. But the way they engineered MD5 hashing is it's irreversible. So he can't pull out that simple math problem and make all the pieces fit together. So anyway, so fun. How do we configure this? Here's what we do. I'm going to go to the router, and the first thing I'm going to do is back out to global configuration mode and create a keychain. Keychain, and you type in a name. So, Jeremy, right? First thing that comes to my mind. Now, that name is case sensitive, so you will have to remember what case you're using. Now, once you're under there, you can see there's not much to this configuration mode. There's essentially key. Configure a key. What key do you want? Let's just go with key number 1. Now, this key number does have to match between all your routers. So, key number 1 on the backbone router has to be key number 1 on the router 2, router 3, and all that. Now, underneath there, you again see it's very limited, but the main thing that you can type in is key string. So let's do sninja. Just like we were typing. That's going to be the secret key that's going to be required by all the routers. Now, we could go a lot deeper into this key command because you can go in and do accept lifetimes and send lifetimes and all this to do automatic key changes. You can see that we can configure 2 billion keys. If you're really bored and paid by the hour, that'd be a great way to go to change keys automatically based on what you typed in. Like if I say, I want to accept this key from, 2 a.m. Until, and you can actually go through and type times and dates and months and years and all that kind of stuff. And you can say, okay, I'll accept this from this time to this time, and I'll send this, I'll use this from this time to this time. So you can actually have your routers on certain dates and times change the keys automatically. Pretty sweet. But we're not going to do that here. I'm going to back out here. Let's go to the other router. Well, actually, let's first off finish it on the backbone router. I'm going to do a do show IP interface brief. Go underneath interface serial 0/0, and I'll do the command IP authentication mode, EIGRP, autonomous system 10, MD5, enter. So it's that command right there just says I want to require authentication when I'm authenticating neighbors on this interface. The next command is going to actually apply that keychain. So I'm going to go in and do IP authentication keychain, EIGRP, autonomous system 10. And then we type in the name of the chain, Jeremy. Now, notice I lost my neighbor on that interface as soon as I typed that in. It's because it required authentication and the other neighbor isn't sending that. So, best thing to do at that point is to do a show run. Let's do section key because I want to see that keychain command. And all I have to do now is copy that. Oh, I should do this too. Hit the up arrow a couple times. Can't leave the other interface out of this, so we'll lose both neighbors. So both neighbors are requiring authentication. Now I'm going to come over here to router 2, exit out, just paste my keychain in there, exit out there, interface 00/0, do IP authenticate. My copy paste happy methods are like, oh, you must go copy and paste. No, I'll type it. 10 MD5. I know I have actually gotten more emails on, Jeremy, how do you actually talk and type at the same time? Honestly, I don't know. I don't know how I do that. So keychain EIGRP Jeremy, right? So now I've got IP EIGRP keychain. Cool. See, I can't. I'm like, I can't because I'm talking and typing at the same time. So let's head over to router 3. Bam, get in here. Interface 00/0. Now I am leaving probably one of the most critical networks out of it so far, this fast Ethernet 0/0 network over here, where there's probably people trying to break into my network, but that's all right. I'm going to go paste my keychain in. Interface 00/0. Let's do that. IP authentication mode, EIGRP, autonomous system 10. And it's so good that on the exam, they actually allow the context-sensitive help to work. I remember back in the day when I was taking Cisco exams, they would have fill in the blank. Now this is like 14 years ago. They would actually, instead of simulations, they didn't have them back then. They would have fill in the blank. It'd say, "What command would you type to do that?" I'm like, I don't know. So you can see right there, we've got authentication turned on, kicking away for our network. From this point on, backbone router 2, router 3 will not form neighbor relationships unless they have that pre-shared key. If that pre-shared key ever changes or that key number changes on any of these routers, the neighbor relationship immediately drops. So if you're ever wondering, like, oh man, how come my neighbor relationships aren't forming, you can always bail out and do a debug EIGRP packets. Really handy command because it tells you immediately what packets are being sent and received. And you can see right here it's saying, oh, I'm sending hello, but look at that. Received a packet with MD5 authentication, key ID 1, and it's like, hey, I'm still saying hello. That tells you that EIGRP is working. I know some of you are like, come on, break it. Okay, so I'm going to go into interface 00/0 on this guy. Let's do no, and we'll just kill that guy right there. No keychain. Look at that. Immediately, it's like, sorry, invalid authentication, dropping the, oh, you see it, right there, dropping the peer, because it is no longer sending the correct authentication. And from there on out, as it's seeing hello messages from that guy, he's like, hey, we're missing authentication. Or if you have the wrong key, it's going to say invalid authentication on the message. You now know how to configure EIGRP security using passive interfaces and authentication. I hope this has been informative for you, and I'd like to thank you for viewing.